11 divided by 2/3, that's the same as 11 times 3 over 2. Same thing. And what is this equal to? Well, this is just 11 times 3 over 2, which is 33 over 2. And so the answer for this one is 33 over 2. Okay. Now, do you have to show all this work on the final? Well, no. I mean, you want to show some work. So if you just showed, let's say, 11 over 2/3 is 11 times 3 over 2, which is 33 over 2, that would be fine. Again, I like to show all the steps because I don't know everyone's math background in this class. I mean, there's no harm in showing all the steps. At least I don't think so. But if you skip this step here and this step, that'd be fine. I know even though it's a take-home final, I understand there is still a time constraint. I understand that. So we get x is 33 over 2. But again, we're not done, right? This was when 2 over 3x minus 7 was 4. We have to check, what about minus 4? Right? We have two equations. Well, it's the same steps though. Namely, we add 7 and then we're going to divide. So we add 7, right? Again, we want to get x all alone. Adding 7, we get 2 over 3 times x is 3, right? We want to get x all alone. So we have 2 over 3 times x equals 3. So 2 over 3 times x we have is 3, okay? And again, just like before, x, we want to get x all alone. So what do? We divide by 2/3, right? We have 2 over 3 times x. We don't want that, so we divide. Wait. There we go. Trying to get the pen here from PowerPoint. There we go. So we get x. We get x is 3 divided by 2/3. Now, you know, it's not really the best way to leave it, right? We can do better than this. And we can. This is the same as 3 divided by 2/3. 3 divided by 2/3, right? That's the same thing as 3 times 3 over 2. And of course, that's the same as 3 times 3 over 2. Right? Again, when you divide, you multiply by the reciprocal. Same thing. So that's 3 times 3 over 2, which is 9 over 2. That's the other solution. All right. Okay. Are there any questions on this one? Okay. This was something else we did, absolute value inequalities. I mean, it's not terrible. Again, you have to remember though, it's like a 2-for-1 thing, right? You have absolute value less than something, right? What do? What you have to do is you get 2 inequalities to deal with. In other words, from here, you're going to have 3x plus 4 less than 9 and greater than negative 9. Less than 9, excuse me, and greater than negative 9. That's what we get here. So we have this compound inequality to solve. That's not so bad. I mean, basically, you're just going to get x all alone in the middle. And again, as we can see here, whatever you do to one side, you do to the others. So for instance, here, we want to get x all alone, right? Okay, so let's subtract 4 from each side. And that's what we're doing, right? We want to get the 4 out of here, but what we do to one side, we do to all the others, you know, keep it balanced. And so 3x, right, we have in the middle. Over here, we have 9 minus 4 is 5. 9 minus 4 is minus 13. Sorry, negative minus 9 minus 4, which is minus 13. I rewrote this inequality like so, as you can see. Then we divide by 3, right? We don't want 3x here, we want x. We divide. And when we divide, we get x all alone in the middle. Here we get 5/3, right? And on the right here, we get minus 13 over 3. So our answer is this here, which we can write as an interval. All right, so that's one example. Again, I am going a little quick through this, I understand, but again, it is review. So, you know, just to help you remember how we solve these. Now, this was one example. Here's another one. Also, I said this for the other class. In the book, they deal with absolute value greater than something, greater than or equal to something. I didn't go through that. That's okay. So again, whatever I skipped, that's in the book. Whatever I skip, you do not have to know. But now we're solving this one. It's really the same idea. From this, we get 2 inequalities, as you can see. Namely, right, from here, we're going to have minus 6x plus 1 less than or equal to 11 and greater than or equal to minus 11. 2 inequalities to deal with. That's okay. We can deal with them at the same time, right? Just like before, we want to get x all alone. How do we do that? Subtract 1 from each side, as you can see, right? We want to get the 1 out of here, so we subtract. What you do to one side, you do to all the others, as you can see. And so minus 6 times x, we get in the middle. That's going to be less than or equal to 10, greater than or equal to minus 12. Now, again, you have to be careful here because we divide by minus 6. All I did here was I rewrote the inequality like this, just to make it look nicer. You know, I brought the less than or equal and the 10 over. When you divide by minus 6, right? When you divide by a negative or multiply by a negative, you have to turn the inequalities around. And that's what I did. So we get x in the middle bigger than or equal to 10 over minus 6, less than or equal to 2. The bottom line here, the bottom line over here, all I did was I just rewrote the above inequalities so that we have less than or equal. This last step you really don't have to do. I just thought it would look nicer, but it's really not necessary. But from here, we get our answer. We get the interval from 10 over negative 6, which is negative 10 over 6, to 2. And that's what we get. Okay, if you forgot to turn the inequalities around, okay, for whatever reason, what you would have is 2 less than or equal to x, less than or equal to 10 over negative 6. And that wouldn't make sense. So, you know, that's sort of a check. Okay, there's one more example here I want to do. But it's just, again, with the quadratic equation, you could solve this equation, right? A quadratic equation like so, using the quadratic equation, which is here. Okay, you know, normally you would have to memorize this, but again, the exam, the final that is take home, so you don't have to memorize it, at least for my final. if you want to use this, you basically have to have the quadratic, right? The polynomial of degree 2 equal to 0. You have to figure out also what A, B, and C are. But that's easy, you just compare. So here, let's solve this equation. We can see that A, which is the leading coefficient, is 1, right? If it's not listed, it's 1. It's understood. If it's not listed and the term is there. If it's not listed, that's better. What I said first, it's not listed. Minus 5x, we include the minus if we're subtracting. Plus 3, right? C is 3. B, remembers the coefficient of x, which is minus 5. C, the constant term, is 3. Now we use this quadratic formula. So we have minus 5 plus or minus the square root, right, of minus 5 squared minus 4 times 1 times 3 over 2 times 1. And you go through all this, you have minus 5 is just 5. And what you end up getting is this. Remember, there are two solutions embedded here. You have 5 plus radical 13 over 2. 5 minus radical 13 over 2. We have those two solutions. And I rounded it to 3 decimal places. That's what I said to do. Where is it? That's what I said to do here. So that's why I got this. Again, notice that I only have numbers here. I've seen students in the past, they would put minus 5x here, minus 5x squared, and minus 4 times x squared times 3. Don't do that. Only numbers that go in here. Okay, well, okay. Let me just, I think that's all I had to say. Let me just say this quickly. B squared minus 4ac, remember, is the discriminant. If this is negative, the solutions are complex numbers. So for us, there are no solutions. When I say solutions here, I mean real solutions. So, okay. So that's really it. So let me stop this.